And now for our fifth example, we're going to talk about how to simplify 6 times the cube root of 540. So this is going to use the exact same techniques that we've been dealing with so far. In this case, we don't actually have a negative to worry about, so we're kind of grateful for that. This is just going to be another factor tree problem. So notice that we have the 6 out here in front. This thing is just going to get carried along for the ride. It's just being multiplied by the radical. We're going to have to simplify this radical, and then 6 is just going to be part of our work. It just gets carried along. So if I rewrite this, I have 6 times cube root of 540. And, well, we need to figure out how we can break down this 540. And hopefully we can do it into powers, or third powers. So let's take a look at 540 and see how this thing breaks down. So notice that the last digit is 0, so this is divisible by 5. And what does that divide by? I have to use a calculator real quick. That gives us 108. So that's one of the things you're going to have to do on occasion. When you have big numbers and you know that, hey, at least 5 divides it, plug it into your calculator. Take 540 divided by 5. So that gave me 108. Now, how does 108 get divided? I know it's even, and because I have this 8 in the ones digit, so it's going to be a power, or it's going to be a factor of 2, and the other one's going to be 54. Okay, this is also even, so this breaks down into 2 times 27, and 27 breaks down a bit further here, so this is going to give us 3 times 9, and 9 breaks down into 3 times 3. So it appears that we have a group of 2 2s, and we have a group of 3 3s, and that's fantastic because we're dealing with a cube root here in the problem. So we're not going to be able to break down too much regarding these 2s or with this 5 factor. But if I were to rewrite this, this gives me 6 times cube root of 5, just rewriting my factors in groups, times 2 squared, times 3 to the third. So now I know that I can cancel off this third root and this 3 here after I apply the power rule, or the product rule in this case. So using the product rule, I get cube root of 5 times cube root of 2 squared times cube root of 3 cubed. Okay, so the 6 is just going to get carried along for the ride. The 5 does not break down anymore, so I cannot take the third root of 5. That's stuck. I also have 2 squared here, and I have a third root. So what I have inside here, since I don't have a cluster of 3 2s, I'm stuck with the cube root of 2 squared. So these will end up getting recombined later. I have a third root of 3 cubed. That cancels. So this ends up being just 3. The 3 in the third root cancels the third power. So rewriting, this gives me 6 times cube root of 5 times cube root of 2 squared times 3. And that 3 is not inside any radical. Rewriting, since everything's being multiplied and multiplication is commutative, meaning I can swap the order, I end up with 18 times cube root of 5 times cube root of 2 squared. And since these cannot be simplified, I'm just going to recombine them, basically applying the product rule backwards. So like I split it up before, I'll just recombine it now. So this gives me 18 times the cube root of 5 times 2 squared. Okay, and this case, I'm looking at 4 times 5, so that gives me 20. So 18 cube root of 20. And at this point, since, as I mentioned before, we couldn't break down these factors any further, this 20 is not going to break down either. So we're stuck with 18 times the cube root of 20. And that is completely simplified in the simplified version of this lovely expression up top. So we are done.